Q1 What do you mean by material? Write short note on cubic lattices. Material. Material is the tangible substance that goes into the makeup of a physical object. It is the matter from which something can be made. Material can include, but is not limited to, raw and processed material, components, parts, assemblies, subassemblies, fuels, lubricants, coolants, cleaning agents, and small tools and accessories that may be consumed directly or indirectly. The primitive or simple cubic system consists of one lattice point on each corner of the cube. Each atom at a lattice point is then shared equally between 8 adjacent cubes, and the unit cell therefore contains in total 1 atom. Body-centered cubic. The body-centered cubic system, CI, has one lattice point in the center of the unit cell in addition to the 8 corner points. It has a net total of 2 lattice points per unit cell. (3) Face-centered cubic. The face-centered cubic system, CF, has lattice points on the faces of the cube that each gives exactly 1/2 contribution, in addition to the corner lattice points, giving a total of 4 lattice points per unit cell. Q2 Define beam, column, free body diagram, shear force, bending moment, stress, and strain. Beams. Beam is the horizontal member of a structure carrying transverse loads. Beam is rectangular in cross-section. Beam carry the floor slab or the roof slab. Beam transfer all the loads including itself weight to the columns or walls. Columns. Column is a vertical structural member. It transmits the load from ceiling/roof slab and beam, including itself weight, to the foundation. Columns may be subjected to a pure compressive load. RCC columns are the most widely used nowadays. Free body diagram. Free body diagram is the diagrammatical representation of the forces and moments on body with directions and appropriate frame of reference. The inertial forces are the net resultant of the forces and moments added vectorially. It is a graphic, dematerialized, symbolic representation of the body, structure, element, or segment of an element, in which all connecting pieces have been removed. Each connection is solely represented by a juncture with distinct properties, or is replaced by a set of forces and moments which would represent the action at that connection. Internal forces which would be found at a node, connection, or joint can be replaced by representational external forces, where that part connects would connect with the other member in the FBD. All loads are represented as force systems. Shear force and bending moment are examples of internal forces that are induced in a structure when loads are applied to that structure. Shear force. Shear force may be defined as the algebraic sum of the loads to the left or right of a point, such that the addition of this force restores vertical equilibrium. Bending moment. Bending moment may be defined as the sum of moments about that section of all external forces acting to one side of that section. Moments, at any point, are calculated by multiplying the magnitude of the external forces, loads, or reactions, by the distance between the point at which moment is being determined and the point at which the external forces, loads, or reactions are being applied. Stress is a measure of the internal forces acting within a deformable body. Quantitatively, it is a measure of the average force per unit area of a surface within the body on which internal forces act. These internal forces arise as a reaction to external forces applied to the body. Strain is the definition of how much a material has been stretched or compressed when compared to its original length. The most common measure of strain in metals is called engineering strain, calculated as the change in length divided by the original length. Q3 Elaborate different kinds of supports. Draw neat sketches of various kinds of supports and possible reactions over them. The beams usually have 3 different types of support. 1 hinged or pinned support, 2 roller support, 3 fixed support. Hinged or pinned support. The hinged support is capable of resisting force acting in any direction of the plane. Hence, in general, the reaction at such a support may have 2 components, one in horizontal and another in vertical direction. To determine these 2 components, 2 equations of statics must be used. Usually, at hinged end the beam is free to rotate, but translational displacement is not possible. Roller support. The roller support is capable of resisting a force in only one specific line or action. The roller can resist only a vertical force, or a force normal to the plane on which roller moves. A reaction on this type of supports corresponds to a single unknown figure. Fixed support. The fixed support is capable of resisting a force in any direction, and is also capable of resisting a couple, or a moment. A system of 3 forces can exist at such a support, i.e., 2 components of force and a moment. The hinged and roller supports are also termed as simple supports,